Good morning all. Today we are going to discuss the application of beam problems. So this is a topic in module 2. So first we will see the definition of beam. So beam is a structural element that is capable of withstanding load primarily by resisting bending. So it is a structural element. You can see beam in various structures. So in the figure you can see the beam. It is a horizontal member. And one dimension, that is the length, is considerably larger than the cross-sectional dimensions, as you can see in the third figure. So now this beam is subjected to transverse load, that is the load is applied perpendicular to the cross section of the beam, and it is supported at few points. So due to the application of the load, reactions are developed at the support, and the system of force consisting of applied load, self-weight and the reaction. So all this force, external force along with the reaction, keep the system in equilibrium. So the force constitutes a system of coplanar non-concurrent system. So we have to apply the three equations of equilibrium. Sigma V is equal to 0, or sigma F Y is equal to 0, sigma Fx is equal to 0, and sigma M is equal to 0. So these are the three equations you can apply for a coplanar non-concurrent system. So while analyzing the beam, that is, analyzing means you have to calculate the support reactions developed on the beam due to the external loads. So you have to remember that the beam is a system of coplanar non-concurrent force. So we have to apply the three equations of equilibrium. Sigma Fx is equal to 0, sigma Fy is equal to 0, and sigma M is equal to 0. That is, you can take moment about any point. So now we will see in detail what is a beam. So beam is a structural element which is subjected to transverse load, that is, load is applied perpendicular to the axis of the beam. Second is its length is large compared to the cross-sectional dimensions. So now the purpose of the beam, that is, load from the slab, floor, wall, etc. is transferred to the column through the beam, and through the beam it is transferred to the foundation. So due to the load acting on the beam, there will be reactions developed at the supports. So in this chapter we are mainly dealing with the different types of beam, different type of load, different type of support, and the reactions occurring at the support. So now we will see the definition of support and reaction. So what is a support? Support prevents the translation of a body in a given direction. So support restrains the movement in a given direction. So a force will be developed in that direction. And second is reaction. What is reaction? So reaction may be a force or a moment exerted on an object by its support. So reactions are developed due to the support. It may be a force or a moment. So now we will see the different type of supports. So first type of support is known as simple support. So in this type of support, beam is simply supported on a support, or there is no connection between beam and the support. So here for a simple support, the end of the beam rests simply on a rigid support. So there is no resistance to the force in the direction of the support. So here the reaction will always be normal to the support. So that is there is only one reaction, that is the vertical reaction. So for a simple support, there is only one reaction at the support, that is the normal reaction or the vertical reaction. Second one is a fixed end support. So here the beam is completely fixed at end in the wall or support. So in the figure you can see the left end is fixed to a wall or a support. So here when the end is fixed, the beam cannot rotate. So left end cannot rotate. So here the reactions developed are, there is vertical reaction, there is horizontal reaction and a moment. Due to the vertical and horizontal reaction, the resultant reaction will be inclined. So the fixed support neither permit to move in any direction or nor allowed to rotate. So at the fixed support you cannot move in a vertical or horizontal direction, and it also restricts the rotation. So the reactions developed are vertical reaction, horizontal reaction and a moment. So that point you have to remember. So there are three reactions at the fixed end support. One is vertical, second is horizontal and the other is moment. In the previous case you are having only one reaction, that is the normal reaction, which is perpendicular to the beam or the perpendicular to the support. Third one is the roller support. So here the beam end is supported on rollers. So the reactions developed are perpendicular to the roller support. So here the rollers are free to roll along the support. So the ends are free to rotate and there is no resistance to moment. So only restriction is for the vertical movement. So the reactions developed is only one reaction, that is the vertical reaction. So this type of support is mainly provided on one side of the bridge. Why we are providing a roller support on the bridge? The reason is due to the braking force of the vehicle and temperature force, the bridge slab can slide over the roller support and damage can be developed to the bridge pier. Bridge pier means it is the support provided for the bridge deck. So that may get damaged, that is bridge pier get damaged if we are not providing roller support on one end. So roller support restrict the movement in vertical direction. So there is only one reaction which is always perpendicular to the support, that is the vertical reaction. Suppose this roller support is inclined at some angle, then the reaction is normal to the inclined surface. That point also you have to remember. And the last type of support is hinge support. So here at the support, the reaction can be developed in any direction. So here at the hinge support, the beam can rotate about the hinge, but it restricts the movement in the vertical and horizontal direction. So reactions may be developed at the vertical and horizontal directions. So at the pin support, there is restriction to the vertical movement as well as horizontal movement, but it permits the rotation. So here the reactions are developed in the vertical direction as well as horizontal direction. So since they are having vertical and horizontal reactions, the resultant reaction may be inclined. So the notation for the pin support is shown in first figure. So now we will see the different type of beams. So as we have already said, the beam is a structural member which is subjected to transverse load, and the load applied on the beam may be self-weight, external load, reactions, etc. So the force system is a coplanar non-concurrent system. So we have to use the three equations of equilibrium. Sigma V is equal to 0, sigma H is equal to 0, sigma M is equal to 0. That is, or in other words, you can say that sigma Fx is equal to 0, sigma Fy is equal to 0, and sigma M is equal to 0. So if you can analyze a beam using these three equations of equilibrium, you can call it as a statically determinate structure. So if you cannot analyze the beam, and analyze the beam means you have to calculate the support reaction. In your higher semesters, after calculating the support reaction, you will be calculating the shear force, bending moment, etc. that you can study in your next sem. So currently we are focusing mainly on the basics for the analysis of beam. Basics start with the analysis of beam that include the support reactions. You have to calculate only the support reaction in engineering mechanics. Further calculation will be continuing in your higher semesters. So if you can analyze a beam using the three equations of equilibrium, then you can say that it is a statically determinate structure. Otherwise, you have to call it as a statically indeterminate structure. So here you have to classify this beam. We are focusing mainly on the statically determinate beam. The first type of beam, that is a simply supported beam. So simply supported beam means a beam which is resting on simple support. This is a statically determinate structure. So we will be analyzing this type of beam. Second type of beam is a fixed beam. So in fixed beam, the both ends of the beam are fixed. So for a fixed beam, you have already discussed that at the fixity you are having three unknowns. So in this figure you can see The beam is fixed on both sides. So one side you will be having 3 unknowns, on the other side again you are having 3 unknowns. Altogether there are 6 unknowns, and the available equation is only 3. That is sigma fx is equal to 0, sigma m is equal to 0, then sigma fy is equal to 0. So you cannot calculate all the 6 unknowns using these 3 equations. So we can call it as a statically indeterminate structure. So there are different methods to calculate or analyze a statically indeterminate structure that you will be studying in your higher semesters. So first beam we have discussed as simply supported beam. It is a statically determinate beam. Second one is fixed beam. It is a statically indeterminate beam. So you are not analyzing a fixed beam in engineering mechanics. Now third one is a cantilever beam. So cantilever beam, one end is fixed and the other end is free. So when a load is applied, it has a tendency to deflect down. If you are applying load in the downward direction, it has a tendency to deflect down. So now in this cantilever beam you have one end fixed. So at the fixity you are having 3 unknowns and the available equation is 3. So you can analyze the support reactions using the available equation. So this is also a statically determinate structure. So we will be analyzing this type of beam in engineering mechanics. So cantilever beam means one end is fixed and other end is free. So now the fourth one. Fourth one is an overhanging beam. So overhanging beam means a beam which extends beyond the support. It is classified into 2. Overhanging beam with a single overhang. That is the first classification, and the second classification is overhanging beam with a double overhang. So first one is overhanging beam with a single overhang. So that is a beam which extends beyond the support in one direction. So if a beam extends beyond the support in one direction, we can call it as overhanging beam with a single overhang. So second classification is overhanging beam with a double overhang. So you can see in the picture. So here you can see an overhanging beam with a double overhang. That means the beam extends beyond the support in both directions. So this is also a statically determinate structure. So we'll be analyzing this type of beam. Fifth one is a continuous beam. So continuous beam is supported at more than 2 supports. So here you can see this beam is supported at 4 points. So this is classified under statically indeterminate structure because you are having 4 unknowns R1, R2, R3 and R4, but the available equation is only 3. So you cannot analyze this type of beam. So we are not focusing on this type of beam in engineering mechanics. And the last one is the propped cantilever beam. Propped cantilever beam means one end is fixed and the other end is supported. So here you can see the porch. The porch, if the slab is supported on a beam, you can call it as a propped cantilever beam. That is, one end is built into the wall of the building and the next end will be supported on columns. So here you are having four unknowns, that is VA, HA, then moment, and at the right end you are having one more reaction, that is the vertical reaction. So altogether you are having four reactions and the available equation is only 3. So this is classified under statically indeterminate structure. So this type of beam we are not discussing in engineering mechanics. But the classification, if you are asked, you have to write all the 6 classifications. So on the right side you can see the various cross sections of this beam. So cross section of the beam may be T section, L section, channel section, I section, wide flange section, etc. Again you can have rectangular section, triangular, circular, etc. So the cross section can take this type of sections. So now we will see the different type of load. So in engineering mechanics we are mainly focusing on point loads that may be vertical or inclined. Again we will be discussing with the moment acting on the beam also, external moments on the beam. But we are not focusing on the other type of load acting on the beams. But we have to write the theory, or we have to study the theory. So first classification of load is concentrated or point load. So here you can see a simply supported beam. So beam is resting on two simple support, that is a wall. So here a point load is applied, W1 and W2 is applied. So this point load occupies a very small area compared to the total length of the beam, or it occupies a very small length compared to the total length of the beam. So you can call it as a point load. Its notation is either Newton or kilonewton. Second type of load is uniformly distributed load. In short, we can call it as UDL. So this is a load acting per meter length of the beam. So it is represented in kilonewton per meter or Newton per meter. So example for this uniformly distributed load is the self weight. That is, the load has same intensity throughout over a considerable length. So example is the self weight of the beam. Self weight of the beam is an example for uniformly distributed load. So the load is given a unit kilonewton per meter, that is 20 kilonewton per meter indicate that 20 kilonewton load on 1 meter length. Third type of load is uniformly varying load, or you can call it as UVL. So the intensity of the load increases linearly along the length. That is why it is called as linearly varying load. So also it is called as triangular load. That is other name for this type of load. That is the triangular load. So this type of load increases gradually, or it varies linearly along the length. Again the unit is same as that of the previous case. You can write the unit in kilonewton per meter or Newton per meter. So the last two type of load we are not discussing in engineering mechanics. We are focusing mainly on the point loads. So now we will see the analysis of beam. So before analyzing a beam, you have to remember certain points. First point is, since the beam system is a coplanar non-concurrent force system, you have to use the three equations of equilibrium. Sigma fx is equal to 0, sigma fy is equal to 0, and sigma m is equal to 0. So here the analysis of beam means you have to calculate the support reactions acting on the beam. So we have already said that the beam is subjected to transverse load. Suppose this is a beam which is resting on two simple support. And it is subjected to a concentrated load W. So first step in the analysis is you have to draw the free body diagram. As we have discussed, simple support restrict the vertical motion. So vertical reactions are developed. If you are naming this support as A and this as B, then the reaction at A is represented as RA. So simple support has only one reaction, that is the vertical reaction, which is normal to the support. So again at B, you are having reaction RB. So this diagram is known as the free body diagram. So while discussing this analysis, first step is you have to draw the free body diagram. So the reactions developed at the support, that is the simple support, is RA and RB. And RA and RB along with the vertical reaction form a system in equilibrium. So you can apply these three equations of equilibrium and calculate the support reactions. So now the second point you have to remember is the reactions developed at various support. That is very important. So for a simple support, there is only one reaction, that is the vertical reaction, and this is the notation for the reaction. So now suppose you are having a beam supported with a roller. So here one end is roller and the other end is hinge. This is the notation for roller support. And this is the notation for hinge support. So here this beam is supported on one end with roller and the other end with hinge support. And again you are having some external load W. So here in this case also you have to draw the free body diagram. So you have to draw the B. You can name the support as A, this as B. So here at the roller support there is only one reaction, because roller always restrict the vertical motion. It permit the horizontal motion and rotation. So it restrict the vertical motion. So the reaction developed as RA. So there is only one reaction which is similar to the simple support, that is roller is having only vertical reaction. So now the next support is hinge. Hinge support permit only the rotation. It restrict the vertical and horizontal motion. So reactions developed at the hinge support are vertical reaction and horizontal reaction. So here you have to name the vertical reaction as VB. Because the support is V, vertical reaction is represented as VB and the horizontal reaction is represented as HB. So now the resultant of this reaction that you have to calculate. So after calculating reaction RA, VB and HB, that is RB. So RB you can calculate using the equation you have studied in module 1. RB is equal to BA square plus HB square. Again you have to calculate the inclination of RB with the horizontal line. That is, this inclination is given as, you can assume as theta B. Tan theta B is equal to VB divided by HB. So this is the final step after calculating the reactions. So this is a very important point you have to remember. If you are provided with roller, there is only one reaction, that is the vertical reaction. And if you are provided with a hinge support in the beam, then you have to mark two reactions. One is vertical and other is horizontal. And you have to apply the three equations of equilibrium to calculate all these three unknowns. After getting the three unknowns, you have to use this equation to calculate the resultant reaction at the hinge. So at the hinge support, you have to calculate the resultant reaction and its inclination. So now the third point you have to remember is, suppose you are having a roller support. Which is inclined at some angle. So here the support is, the roller support is provided. So here the notation is like this. So if the roller support is provided, which is inclined at some angle, you have this inclination as 30 degree. So you cannot draw the reaction like this. This is wrong. So here you have, what you have to do is, you have the beam like this, and this is the roller support, which is inclined at 30 degree. Here the reaction is always perpendicular, that is, this angle is 90 degree. So the reaction is perpendicular to the roller support. So you have to mark this reaction as RA, which is perpendicular to this roller surface. So it should be perpendicular to this surface. This is 90 degree. So this is another point you have to remember. So now the next point is, suppose you are having an inclined load. Whose inclination is given as 30 degree. So before analyzing the support reactions RA and RB, you have to consider the components of this 20 kilonewton. So here the vertical component is 20 sine 30 degree, that we have discussed in module 1, and the horizontal component is 20 cos 30 degree. So while analyzing, you have to take this components instead of this force 20. So now the next type of support we have discussed is the fixed support. So this is the notation for the fixed support. So fixed support restrict the vertical motion, horizontal motion and rotation. So here the reaction developed at the at the fixed supporters, vertical reaction VA, horizontal reaction HA, and the moment is given the notation MA. So here we are assuming the direction of the moment. We are assuming it as clockwise. So if a fixed support is given, you have to draw these three reactions. So all this point you have to remember while analyzing a beam. So this is a very important topic. So now we will see the first question. So you are provided with a beam 6 meter long, which is simply supported So here you are given two loads, 10 kilonewton and 20 kilonewton. So now this length is 2, this is also 2. So total 6 meter length. So you have to find the support reactions. So now the first step is you have to draw the free body diagram. So free body diagram for a beam with a simple support is same as that of the question. So here these are the two reactions. You have to mark the reaction as RA. Here the reaction as RB. So now the load acting are 10 kilonewton and 20 kilonewton. So now this represents the free body diagram. So this is a 3-mark question. So 1 mark for this diagram. So now you have to apply the equation of equilibrium. First equation is sigma fx is equal to 0. So you don't have to use this equation because there is no horizontal load. All the loads are external. The reactions are also vertical. All the loads are vertical. So here reactions are vertical. 10 and 20 kilonewton is again vertical load. So there is no need to use this equation. Second equation is sigma Fy is equal to 0. So we have to use the sign convention. Upward force is taken as positive and downward force is taken as negative. So equation RA plus RB. Then minus 10 minus 20 is equal to 0. So we can rewrite this equation as RA plus RB is equal to 30. This is the first equation. So now the third equation is sigma moment about any point is equal to 0. We are taking moment about A. We are taking moment about this point. So first force is RB into this perpendicular distance. So RB into perpendicular distance is 6. This is anti-clockwise moment. So RB into 6, that is anti-clockwise moment, that is positive. Then next force is 20. This is 20 into perpendicular distance to A, that is this length 4 meter. So 20 into this length, that is a clockwise moment, that is negative, minus 20 into 4. Next force is 10. 10 into perpendicular distance to A, that is this length. So 10 into 2, that is also clockwise moment. So minus 10 into 2 is equal to 0. So RB is equal to 20 into 4 plus 10 into 2 divided by 6, that is equal to 16.67 kilonewton. So now after getting RB, you can substitute in this equation. So RA is equal to 30 minus 16.67, that is equal to 13.33 kilonewton. So these type of questions are very important. So now the second question. So in the second question, you have to again calculate the support reactions. So figure is given in the question. You are given a beam. On one side it is supported with roller, and the other end it is supported with a hinge support. So total length of the beam is 8 and load acting on 4 kilonewton, that is acting at a distance 1.5 meter from A. Then next force is 10 kilonewton, which is at a distance 2.5 meter from 4 kilonewton, and the last force is 7 kilonewton, which is at a distance 2 meter from 10 kilonewton and 2 meter from the next support, that is B. So now here you are provided with a roller support at left end and hinge support at the right end. So first step is you have to draw the free body diagram. So at the roller support there is only one reaction, that is the vertical reaction, that is represented as RA. So at the hinge support, so for the hinge support we are having two reactions. One is the vertical reaction VA and the next is the horizontal reaction HA. So before marking this reactions at the hinge support, you have to refer to the external load. So here you can see all the external loads are vertical. So there is no need to draw this reaction HA because there is no external horizontal loads. So at the hinge support, it resembles a roller support because the external loads are vertical. So instead of VA, you can represent the reaction as here it is VB and HB. So instead of VB, you can represent this as RB. So why we are taking this reaction as RB? This is actually hinge. It is having two reactions VA and HA. But when we refer to the external load is vertical. So hinge resembles the roller support. So it is having only one reaction, that is the vertical reaction. So now you have to mark all the external loads. This is 7 kilonewton, 10 kilonewton, then 4 kilonewton. So this is the free body diagram. Next step is you have to apply the equations of equilibrium. Here you are having all the external loads that is vertical. So sigma fx is not applicable. Sigma fx is equal to 0. We don't have to take this equation. So you have to take the first equation as sigma fy is equal to 0. So again the sign convention is upward force is taken as positive, downward force is taken as negative. So here the equation is Ra plus Rb minus 4 minus 10 minus 7 is equal to 0. So Ra plus Rb is equal to 21. That is the first equation. So now the second equation we are using as moment about any point is equal to 0. We are taking moment about A. So we are using this force Rb. Rb into perpendicular distance to A is this length. That is equal to 8. So Rb into 8. And that is anti-clockwise moment. Positive force into perpendicular distance. That is anti-clockwise moment. Positive value minus 7 into perpendicular distance is 2 plus 2.5 plus 1.5. So that is equal to 7 into 6. So 7 into 6. You have to multiply with this distance. So 7 into 6, that is a clockwise moment. Then 10 into this distance. So that is equal to 4. 10 into 4, that is also clockwise. Then 4 into this perpendicular distance. 4 into 1.5, that is also clockwise, negative value. So minus 10. So 10 into 4 minus 4 into 1.5 is equal to 0. So you will get the value for Rb as 7 into 6 plus 10 into 4 minus 4 plus 4 into 1.5 divided by 8. So Rb is equal to 10 kilonewton. And from the first equation you will get the value for, so here Rb is equal to 11 kilonewton and Ra is equal to 10 kilonewton. So now the third question. So here you are given a you are given a beam which is supported with a hinge and a roller support. So here the load applied are 10 kilonewton and 20 kilonewton. So here the 20 kilonewton load is applied at an angle 60 degree. So now the length are given. This is support A and this is support B. You have to calculate reactions at A and B. So first step is you have to draw the free body diagram. So at the hinge support you are having vertical and horizontal reaction. So before marking the horizontal and vertical reaction you have to refer to the external load. So it is inclined at an angle 60 degree. So the component of 20 kilonewton in the vertical direction, that is 20 sine 60 degree, that is the vertical component. Horizontal component is 20 cos 60 degree. So here this force has one component in the vertical direction and the other component in the horizontal direction. So at the hinge support you have to mark two reactions. One is the vertical reaction and other is the horizontal reaction. So if the external load is inclined, you have to mark both the vertical and horizontal reaction at the hinge support. So now at the roller support you are having only one reaction, that is the vertical reaction, that you can represent as RB. So now here you are having 10 kilonewton. So this is the free body diagram. So now using this figure you have to calculate the support reactions. First equation is sigma Fx is equal to 0. So here you have to use this equation because you are having two horizontal forces, HA, that is towards the left, and 20 cos 60 towards the HA towards the right and 20 cos 60 towards the left. So here you have to use the sign convention. Right horizontal force is taken as positive and left horizontal force is taken as negative. So HA minus 20 cos 60 degree is equal to 0. So you will get the value for HA as equal to 20 cos 60 degree. So HA is equal to 10 kilonewton. So now the second equation is sigma Fy is equal to 0. So you have to consider all the vertical force. So sign convention is upward force is taken as positive, downward force is taken as negative. So VA is upward, RB is upward. So VA plus RB minus 20 sin 60 minus 10 is equal to 0. So VA plus RB minus 20 sin 60 degree minus 10 is equal to 0. So from this equation VA plus RB is equal to 27.32 kilonewton. That is the first equation. So now the next equation we are using is sigma moment about any point is equal to 0. We are taking moment about E. So here you have RB into this distance, perpendicular distance to A is 6. RB into 6 is an anti-clockwise moment. Then you have 20 cos 60. This is a horizontal force which is passing through the point A. So it will not create a moment. Then next force is 20 sin 60. It is acting at this point. Perpendicular distance to A is this length. So 20 sin 60 into perpendicular distance, that is 4. 20 sin 60 into 4. That is a clockwise moment. Then next force is 10. 10 into so 10 into 2. So that is a clockwise moment. So now we can substitute in the equation. Sigma moment about A is equal to 0. So RB into 6 minus 20 cos 60 into 4 minus 10 into 2 is equal to 0. So from this equation RB is equal to 14.88 kilonewton. Then VA is equal to 12.44. You will get the value from this equation. Then after getting VA, you can calculate the resultant RA is equal to root of VA square plus HA square. That is equal to 15.96 kilonewton. Then the inclination of RA with the horizontal, that is theta A, tan theta A is equal to VA by HA. So theta A is equal to tan inverse of VA by HA, that is 38.79 degree. So we will continue with this topic in next video. So thank you.